Why didn't the two parallel lines recognize each other? Because they had never met. Get it? They never intersected. They don't meet. Anyways, we're going to be talking about parallel lines and how to show if a certain angle relationship is true, then the lines have to be parallel. So first of all, let's take a look at intersecting versus parallel lines. If three lines intersect at three different points, they form a triangle. So I actually created a GeoGebra applet, which I'm about to show you, that has a triangle, and when the three lines meet, the triangle fills in. So I'm going to adjust the two angles until you can no longer make a triangle. So this is the triangle we're going to start with. So here I have the triangle that I created on the applet. This angle is supposed to be 59 degrees, and that's 112, and I seem to have my color switched, but that's okay. So let me go ahead and increase this angle right here until it is no longer a triangle. Now, one thing that you may not notice is that even though I'm increasing that angle, it is still connected right there. So if I move it, let me go ahead and move it. So I'm going to increase this angle some more. Whoops. Increase this angle. So right there, even though it is so far away, I've still got a triangle. I'm zooming out so you can kind of see it. Zooming out and moving. See, there's the point. So even at 59 degrees and 120 degrees, those add up to 179 degrees. That's a tiny little 1 degree angle. Well, what happens if I increase it just one more? My angle went away, and you can see there it is, 121 and 59. So let me zoom in just a little bit. And the main point is once I created this relationship here, 59 and 121 degrees, I didn't have a triangle anymore. Let's say if I go bigger than 121, so let me go just to 122. Oh, if I go to 122, that's basically going to give me a triangle on the other side. So let me zoom out so you can see what I mean. See, there's the point. And let me zoom back in. And you can see it. Zoom back in. And if I again adjust it back to the 121, then that is when there is no triangle, assuming I can get 121. So basically, if I make these two angles supplementary where they add to 180, the lines have to be parallel in Euclidean geometry. Why is that? Well, if it was less than 180, I could make a triangle and it would be some tiny degrees. But when it's equal to 180, what happens is that I can no longer make a triangle. I can make these lines that they'll never meet because I've used up the 180 here, and the angle out here turns into 0 degrees. Now, one thing we saw that when lines that do not intersect, so if they no longer intersect, then they are parallel. Remember, they're not going to meet. So the relationship we saw was that they are supplementary. They add up to 180 degrees. This leads us to the converse of the same side interior angle theorem. That is, if same side interior angles are supplementary, then the lines are parallel. So what other angles could be supplementary? What I'm going to have us do is, I know angles C and F are supplementary because M and N are parallel. Should have arrows, but it doesn't. And we're going to shade in the vertical angles in the figure there to determine what other pair of angles are also supplementary. So I'm shading in angle A and angle H. Well, if the yellow and the green here are going to add up to 180, then these two angles are also going to add up to 180 because they're the same size. So A and H are supplementary. What kind of pair of angles are those? They are same side exterior angles. See, C and F are on the inside, and A and H are on the outside of the two parallel lines. This leads us to the converse of the same side exterior angle theorem, which basically says If same side exterior angles are supplementary, that is, they add to 180, then the lines are parallel. So in this example, what we're going to determine is what theorem allows us to say that line U is parallel to line T. So I can see the two angles here, 122 degrees and 58 degrees. Those are supplementary. They add up to 180. Well, what kind of pair of angles do I have? They're on the same side of the transversal, and they're on the outside of the parallel line. So they're same side exterior angles. Well, the theorem that allows me to say that lines U and T are parallel is the converse of the same side exterior angle theorem. So for further reflection, what type of polygon do we make when the lines are not parallel? And why do you think the lines have to be parallel if the same side interior angles are supplementary? And hopefully you realize that because all the angles in a triangle add up to 180, if we put all the angles, the 180 down here, then this is 0, meaning it never meets.